Hi everybody, welcome to the Introduction to R session, which should have followed on from the Introduction to Statistics session. So hopefully with this session, you should be using a lot of the knowledge that you've used from that previous one. We're going to put it to work in doing our statistical analyses in R. So first off, well, you might be wondering, what is R? Well, R is a statistical programming language used for wrangling, summarising, analysing and graphing data. So essentially, it's a way for you to set up a reproducible workflow where the code that you write outlines exactly what you did in your analyses. Now, the reason why a number of people use this in their analyses is that it's free and open source. So essentially, it means everybody can see how it works, and anybody could fork this and make their own version of R if, for example, anybody tried to lock it down at some point. So essentially, it's always going to be free forever. So no matter where you are in the world, you can download it and use it to do your analyses. Now, the nice thing about R as well is that the packages that are used for implementing certain analyses in R, or maybe making certain graphs, tend to be vetted by reviewers on CRAN, the Comprehensive R Archive Network. Now, what this means is that you know generally that any packages that are accessible readily from CRAN are going to be pretty high quality. They're going to be well documented, and they're going to hold some examples in it to show you really how the code works. That tends to be the case. Now, often R is used in conjunction with RStudio, and that's essentially, it's not, it's free to download for personal use, but they are a for-profit company. Now, RStudio is essentially an IDE, basically a development environment that makes working with R just a little bit nicer. So the nice thing about this is, for example, when you create some variables that you want to do some operations on, RStudio will show you what your variables are at all times, instead of you having to use commands to see what you've recently used or created. Now, generally, it's got some other nice things like integration with Git for doing version control on your code, and other just nice extra things. Now, the nicest thing that I use it for is for writing Rmarkdown documents, which is a reproducible document where you can maybe write a full report and insert R code into that report, so you can see exactly what you want to do, when and why in your document. So why should you care then? You're probably wondering, well, if you've performed any analyses in other software packages using point-and-click interfaces, it's a lot less overheads with these other packages than there are using R. Well, one of the big issues is that, at least highlighted by Veldkamp and colleagues, that 63% of articles have included at least one p-value that was incorrect given the reported test statistic and degrees of freedom, which is essentially just a marker of sample size. So one way that we calculate p-values is using things like test stats and degrees of freedom. Now, what this means then is that 63% of articles are reporting their statistics incorrectly in some way. Now, more significantly, in around 20% of these cases, these errors lead to erroneous decisions about statistical significance of the effect. So what this means is people are saying there's an effect when there really isn't one from the stats that they've done, never mind the population or anything that they've looked at. So this means by using simple errors with transcription, the accuracy of your statistics has been decreased. So really what we should be aiming for is transparency in our analyses. Now, the nice thing about R is that it really increases transparency because you can share your code very easily with other people who can verify that they can get the same numbers from it and that your method for generating those numbers is accurate. Now, given the scientific claims often rely on form analyses, Klein and colleagues highlight that this transparency is crucial for assessing credibility. Now, I don't know if you're aware, but at least in psychology and other social sciences, there really has been what we call a replication crisis in recent years, showing that essentially there's a bit of a problem with the way people have been doing statistics in the past. So we want people to vet the stats that people are doing now and be certain that we can be confident in the claims that people are making. Now, the nice thing as well about R is that it's very rapidly developing. So this allows you to get on board with a number of new analyses and adopt those quite easily and quite quickly, because statisticians typically tend to develop for R. Now, for example, if you want to do something like multi-level modeling, R has been the premier way for you to do that for a long time now, because the interface for doing that in R is very neat and consistent, and it works well. So the nice thing about this is because so many people use it for analyses, there's basically so much information out there to help you learn R in some way. So if you have a question, somebody else has probably already asked it by now. So then how do you install R? Well, personally, I always work off a local install, and that's just because I can harness more power on my machine. So I know I've got a pretty good CPU and lots of RAM on this computer, so I'm quite happy to do most of my analyses on this computer. Now, you can do that by following this link to download R from CRAN, or if you just Google the R download, you'll be able to find this on the Comprehensive R Archive Network. Now, when you're on that, you need to choose a mirror from which to download R. So let's have a look at doing this here. So I've got this R, I'm on CRAN here, and I want to download R. Now I'm using a Mac right now, so I just click this link, download R, and now I need to choose a mirror. So it's hosted all over the world. I'll even just go for this top one. It really doesn't matter what I choose. And for me, I'd choose download R for Mac. You choose R for Linux if you're a Linux user, or Windows for Windows. So I'll go here, and basically I just want to pick this top latest release. So this is the latest release that they have, and it tells you when it was downloaded. Now, it's always a good idea to try and keep your version of R up to date by reinstalling it every now and then. And that just allows you to kind of make sure that you're not having any errors in the algorithms that are being kind of performed. So these are constantly being updated. It's just going to help your analyses be as accurate as they possibly can be. So we're done with that now. So you know basically how to install it here, but here's some general instructions to follow along from this point. Now, of course, I know that a lot of you will be working in the university and you might not have access, like admin rights, to do this on your own computer. So a nice alternative instead is to use RStudio Cloud, which I'll get to in a moment. But first off, I want to say, well, what is RStudio and how do you install it? So I've already mentioned that it's an IDE for RStudio, which essentially just makes working with R a little bit easier, and it's got a number of extensions to make certain regular tasks in writing code and formatting your work very easy. So for example, these slides that you're looking at right now were generated using Rmarkdown, which is very easy to work with in RStudio. So what you need to do is go to the RStudio website here, then select the products and choose RStudio. So you'll open up a link like this. I go to products, click RStudio, so it says it's an IDE for R. Download RStudio desktop, and you should be able to get this version downloaded here. Now it has lots of help on board here, so they've got a quick video here, and there's loads of like abouts and blogs on basically how to do quite a lot of different things here. Now, interestingly, a lot of the major developers who work on R on these tidyverse family of packages that we'll be using today work for RStudio. Now, reading some extra stuff about this here is really useful to have so much information on all the different packages that they have here. And basically one of the reasons I use this is because it's so well documented. So it's easy for you to know how things are working. So for now though, we'll leave that there. That's how you just download R, install it, and then download RStudio to get started. It should automatically pick up on the version of R that you have on your computer when you open RStudio, so you should be pretty much good to go straight from there. Otherwise, you can get started on RStudio Cloud to do everything online. So this is a really good option if you do, as I said, if you don't have admin rights to your computer. So all you need to do is go to RStudio Cloud, which I have open here. So it's rstudio.cloud. You'll automatically open up on projects when you make an account. But what I want you to do is to sign up for an account by clicking sign up on the home page. And you can really register quickly and easily if you already have a Google or GitHub account. So I went with the GitHub route. Otherwise, you can register with an email address in the regular way. This is a really easy route for you to get started in RStudio. And the nice thing is, basically nothing's going to break because it's all on the cloud. It's all on their machines. So you can't really do any harm. It's not that you really could do much harm on the computer with R anyway. Now, the only thing I'll say about RStudio Cloud is it can take a little bit longer to get your projects up and running, just because you're doing computation online. And I don't know what the limits are on processing power, but I can't imagine they're all that brilliant. So you just need to know that for most purposes, it should be perfectly fine. But if you want to do really advanced, quite heavy duty stuff like doing Bayesian modeling using lots of simulation of data, then maybe you don't want to go the RStudio Cloud route unless you have access to like a computing cluster. So with RStudio Cloud, as you notice, it should have this sort of display on the right hand side here. So this is what we call our workspace. So I'll show you right here, this is my workspace where it has all of my projects. Now projects are essentially just a container which has everything I need to do to get my project started. So when we go back to here, I might want to start a new project by simply clicking this new project button in the top right. It's going to take a little bit of a while to get started because it needs to just make an instance for everything on their servers. Now once you do that, it'll open up with the traditional RStudio interface that'll look exactly the same as if you're using RStudio offline. You can rename your project once started, and it'll probably make sense for you to give it something like IOC Intro to RStats as a name, just to make sure you know exactly what that project is about. And we'll use everything in this to create a codebook to explain, basically give you a crash course in R. What's all the interesting things you can do in R and how easily can you do it very quickly. Now this session won't be giving you an in-depth overview about all of the commands in R, so I'll try and explain things as I go along. But of course, understand some of the basics in programming will help you get started a bit more. Now I do have a resource that I can link you to later on, which talks you through going from the very basics all the way up, assuming no programming knowledge. But for a 1 hour session, I think this should be enough to just get you started to show you what can you do in R, how useful is it. So we'll start a new project here. So once you've registered, you should have something that looks like this. Obviously it's got my name up there, that should be yours as well. I'll start a new project. So I'll type new project here. And it should say it's going to deploy the project. It might take a little while to get started, but once it does, I can have some options of maybe renaming the project to something a little bit better than untitled project. So while that just starts up, I'm going to go back to the slides and progress a little bit. So the general lesson plan that we're going to do is I'm going to cover some of the basic concepts in R. So we're going to cover importing data. So let's say you have a data set from maybe an external file somewhere. How do you get that data into R for doing your analyses and everything with it? First off as well, now I intentionally took some quite messy data to do this. So we're going to look at how do we clean up our data and then perform some basic operations on it. So we want to do things like filtering out some observations. How do we summarize our data? How do we get rid of any levels that shouldn't really be there, or make the data look a little bit more consistent as well? So we've got a really horrible data set where the people weren't being consistent in how they name things. We're going to summarize the data then once we've got all that. So we're going to take all of our raw data, which is essentially looking at an experiment of several participants on a trial by trial basis. So they have what you might even call replicates if you're in another field. But for me, I think of them as trials. So each person does several trials, and we want to make a summary of that per person. So what's everybody's averages per experiment? So we're going to do that by making some descriptive statistics, so making means and standard deviations, and we're going to make some graphs as well to go along with this. After this, we're going to do some inferential statistics. So we're going to think, well, would the effects I've observed in my sample scale up to everybody else? So for this, we're going to do some simple linear regression analyses. Now, as I said earlier, some further explanations are available by my R for Psych webbook. So this is an R course aimed primarily at psychologists, and it assumes a bit of a background in statistics, but not too much basically. And the nice thing is it assumes no background at all in programming. So if you want to get started here, I'll teach you the very basics, all the way up to quite advanced multi-level modeling. So first off as well, I want you to access the files. So this has got started now. We have our untitled project. So before I do anything, I'm going to call this IOC Intro to R. So I like to name things as new concepts go between underscores, and then the same thing is with dashes. It's just a convention I like to use. So where can you access the data? So we're going to have to work with some data here. Well, if you go to GitHub, I have my GitHub site is here. So it's github.com /GP_Williams /IOC_intro-2-R-stats. So this is a repository for this intro to stats and R course at the Institute of Coding here at Sunderland. Now, the nice thing is you can see how I've made some errors as well in my commit messages, so what I've done. But this is basically just tracking this project while I've made everything. So here's the intro to stats stuff. So actually you can see that here is the HTML file that I used to give my presentation before, and here is an Rmarkdown file that I used to create this presentation. So Rmarkdown is essentially a way for writing documents in R using a markup language, Markdown, which is very quick and easy to use. What that means is you can write the content for things and then the styling happens externally, like using things like CSS. So if you want to have a look at how I actually made all the code for my presentation, you can find it here. Generally in here I'll have some data and images as well where I draw on things for the presentation. But if I go back, if you want to get this information, you can either take a branch of this and start your own version of the project on GitHub, or you can clone or download this entire repository to your own computer. So we'll just do a download zip. This should be the easiest way. It doesn't require anything. So just click clone or download zip, and you should find that my downloads file is going to save here. So I'll just say save here. So there you go. You'll notice that this is going to be downloading now. Everything should be here. So this is the zip file. Make sure, especially if you're on PC, that you unzip this before you try and work with the contents, otherwise things won't work properly. So I'll unzip it. Here's my master file, and I go here. So I've got intro to R. So this is what we're going to work from today. So this is where you can find everything I used to make the presentation. And the most important thing for us is this data file. So if I click in here, we've got this file called lexdec raw. So what does this look like? Well, let's double click and have a look. So for me, it'll open up in numbers. For you, it might be Excel or something like that. Now, what we have is, here's an individual participant, participant A1. Here's the numbered trials that they took part in. Their native language is English, and they're doing a lexical decision task. So they're trying to decide, is the word owl a real word? Is the word mole a real word? Is the word cherry a real word? And these words have classes. The first two are animals, the next one is a plant. The words also have word frequencies, so how often they occur in every 1 million words that people typically encounter. So the higher the number, the more frequent these words are. And on top of this, you have the word length. So this owl is a word of length 3 because it has 3 letters. Mole has 4 letters. Simple as that. This person got this item correct. They got pretty much everything correct up to this one here. And their reaction times are recorded in this bit here. So how quickly did they perform the task in milliseconds? So this seems, that's excessive, this amount of information in terms of decimals here. There's probably no way we could record that accuracy, but it's just to give you an idea about what the data looks like. So anyway, we'll close that for now, and we'll return to our presentation. So we're going to make a code book first off. So you can write scripts in R that only allow you to see your R code and your comments. Now that's just a simple R script. So all you can put in is code or anything that's not going to run, which is commented out. But it's useful for you often to have a code book, which allows you to document what you've done, when and why. Now, generally, you should be explaining like why it is that you're doing things. The how it's done is kind of documented already by your code. Now, in R, these code books take the form of Rmarkdown documents. Now, as I mentioned or alluded to earlier, this is a simple markup language and it allows you to create and control what's displayed separately from your code. I've also put a cheat sheet into this presentation, which links to a PDF from RStudio themselves, showing you how Rmarkdown works. So I might write a header like this, so 1 hash before the header, or 2 hashes if I want a level 2 header. And this is what it'll look like in the presentation. So here's header 1, here's header 2. Here's some plain text in English, and you can see italics with 1 asterisk and bold with 2 asterisks, or you can use underscores. But for now, it's just, you don't really need to care about the details of that right now. It just shows you basically what you can do with Rmarkdown. So why don't we get started with this? We're going to make an Rmarkdown file using File, New File, and R Notebook. So if I go to RStudio Cloud here, I'll go to File, New File, and I'll pick R Notebook for now. So you can do Rmarkdown, and there's different flavors for these Rmarkdown files that you want. And here you could select that you want an HTML output or a PDF output from the document. And what this will do is it'll allow you to basically write all your code and then compile that document into PDF or HTML output. But you don't see the changes on that as you go on. While with an R Notebook, every time you save it, almost recompiles itself, and you can see a preview of it in the one of the panes. So we'll do this. We'll make an R Notebook. So again, this might just take a little while. It's going to ask me to install some packages because this is my first time opening up this this project. But once I've done this once, it'll be remembered every time I open the project again. So say yes, and you'll see that it's going to pop up with some loading screen in just a little bit saying how it's trying to install everything. Now it should work perfectly fine. I can't see any reason why it wouldn't. So here's the install. Everything's happening fine here. And it's just going to get everything loaded in. So that's that. Now the nice thing is when it starts off straight away, it gives you a default title. It's called R Notebook, and the output is going to be HTML Notebook. Now this is YAML or YAML, yet another markdown language or markup language, which essentially just controls the presentation of the output. So you just want to leave this alone. All the content you change is going to be this text. So they've given you some basic placeholder text here to show this is how you present a link with a hyperlink. And this is how you'd put something in italics. And this is called an R chunk. Now, crucially, this is where your R code has to run. You can only type R code in here. And you know that because it says R. Actually, you can put Python code in if you know any Python, where you just change this from R to Python instead. But what should happen is when you have a code chunk, you press play and it shows you how that code works. Now this code works because plot is a default R function and cause is a default R data set that they have. But anyway, we'll leave this for now. So we maybe want to save this. So notice so I'll explain how this all works right now. So this is your editor where anything you write here can be saved. And you can rerun this code whenever you like, okay? Your console is where the code is executed. So see how it ran plot cars here. Now you can work in the console, but generally once you've typed something, it's lost. So it's always a good idea to type in the editor and then execute things in the console. Your environment shows any variables that you've created or the history of anything that you've performed. So you did plot cars earlier here, but I tend to just stick to the environment view. This shows any plots that you've created if you save them or export them anywhere, and you can export them using this tab. And this is your files. So this shows what do you have in this workspace for this project. So we'll progress. So I've already explained what all these parts are. The nice thing is that let's say that I didn't understand, for example, what this plot function did. If I type this into the console, plot, then in my files, I'll get this, it'll change to the help tab here and it'll explain this is plot. It takes X and Y as inputs and some additional input. And it explains what these are typically like. It shows generally what the output will be and it gives some details of how the function works. But we don't need to know all of this for now. So we've talked about all of this. So let's make our codebook. So I've talked about the editor window. I've explained what happens in that first kind of the YAML header, so you don't touch that. But we want to save this file. Now, as I said, by default, our notebooks shows you some of these code chunks and how these work, and I've just ran through that as well. Now, importantly, RStudio automatically creates an RStudio project. See this little thing here within your workspace in your files list, which almost acts as a way for setting your default working directory. Okay, so essentially whenever I use packages which use relative file paths, whenever you open up an RStudio project, it sets that as your working directory. So if I want to read in a file from the same directory as my project, I don't need to tell it to look in any subfolders. That's really nice for sharing your data with other people or your code with other people, because you want to generally avoid using absolute file paths. So that's normally a bad idea because people don't have the same file paths on the computer as you. So just talk about things in terms of where they are relative to your project. So I seem to skip through a little bit. So let's go back to this. We're going to save this. So I can just type save here. Let's give the file name a name. So it can be, I'll just call it report for now. So you'll see it saved as report.rmd, and now in my files list, I've got my report.rmd document, which is where I work from. And this is basically the preview HTML file. So if I click this preview link, I should be able to see it. I need to obviously got my preferences and allow pop-ups for RStudio here, and you'll get this pop-up. So this is my notebook. Here's my text, so you can see how it's changed from the code in R, and here's my output, which is showing the plot. Now automatically, you can hide these code chunks if you want, or you can hide them using options in your code chunks, but I'll not really cover that here. So we'll say cancel there. So let's return to it. So first off, what we want to do is install we'll just install this one package today. So I'm not going to install the here package for now, but it's something that's really useful for you to use in the future, which just makes working with relative file paths a bit nicer. So we're going to install the tidyverse package. You need to install a package only once per computer or once per project. After that, though, every time you log into that project or every time you open up R again, you need to load it using this library function. So this installs it, install packages. What packages do you want? Tidyverse. Then I'll load it using library tidyverse. So let's change this R chunk here. We'll do install.packages. In fact, because I'm only going to do it once per computer, I'll put this in my console. Tidyverse. So you should see this should execute the code. Again, this is quite a heavyweight package, so the tidyverse is actually a package of packages that makes working with R just a hell of a lot easier than using just base R. So it's going to install them into this project, and we should be fine to go. So why don't we call this chunk load packages? So always use a dash between names when you're naming a function, a chunk here. And the reason for this is that when it's executed, when you recompile the script, it'll tell you maybe what the name of the chunk is if a chunk fails somewhere. So it's useful to know what the name of it is. So I'll do, I'll call this one while that's loading, library tidyverse. Now it doesn't matter if you have the quotes around the string or not here, it should work exactly the same. So then, while that's all installing, we'll just get started. So it's generally a good idea to put all of your packages at the start of your code chunk. I'll get rid of this text here as well, and I'll get rid of this text because we don't need it. So I generally load all my packages first, and then I'll do some other things. Now for me to insert another code chunk, I just click this button here, insert, and I'll put an R code chunk in. And there you go. Or you can literally type this out yourself if you want, but it seems a little bit of a long-winded way to do it. So I'll save this because I've installed those packages. I'm going to load the tidyverse. And you see it has these ththings like ggplot and dplyr, which are very useful packages for us.